Dear friends, in the series of landing aerodynamics, let us discuss on the aircraft performance. So this is the part 3 of that climbing flight. So yeah, okay. What we are going to see in this class, how to find out the rate of climb as well as angle of climb. From the hodograph. So hodograph, that is nothing but it is drawn based on the vertical velocity and horizontal velocity. So this is the vertical velocity and this is the horizontal velocity. So it is drawn based on the this. So we all know this is the v infinitive. So if you draw the vertical and horizontal velocity, if you say this is the vertical and this is horizontal, then this is the resultant. So this is the angle. So the graph between vertical velocity and horizontal velocity, so what we call it as hodograph. Particularly this hodograph or this climb hodograph is drawn for particular altitude. That is very important because we are not taking the different altitude. At particular altitude, how to achieve the rate of climb, that means maximum rate of climb and also maximum angle of climb. So that is what we are going to see in this. So now this is the hodograph. So between vertical axis and horizontal axis here, for given angle, so at a given velocity, then how to find out the angle. So that is what, suppose if you say this is the at a given velocity, so at this velocity what is the theta, so what is the angle of climb, so that we can find out. So this velocity is nothing but we can just say as the rate of climb. So for a given rate of climb, how to find out the angle of climb, so that is we can just find it from here. And then next important thing is, as we are increasing the angle of climb, then as we are moving high and high, above and above, what happened, it is reaching the that means as we are just moving above and above, it is reaching at one point where the rate of climb becomes max. So that is what we say angle of climb. That means rate of climb reaches maximum at a certain angle. So that angle we are representing as the theta. So this is also theta, and this is nothing but where the maximum rate of climb is achieved. So at this point only, so as we say this is nothing but we can just see as the rate of climb maximum at this point. So this point. So at this point, what is the theta, what is the angle of climb, so that we are finding it from here. Then next thing is as we still we are moving further, then what happened, we are reaching the maximum angle. So that is what, so from the graph, as we are seeing that, so we are drawing the tangent to this curve, this hodograph curve, then we are finding it where it touches. So that is what we say angle of climb. So this is nothing but this is the theta max and maximum angle of climb, at which what is the, so we can just say this is the rate of climb at theta at theta max. So that is what we have to understand. Then similarly we can find out what at what velocity we are just achieving the maximum rate of climb, as well as this is the rate of climb, and flight also will have some velocity. That velocity is just horizontal velocity we say. So with respect to the vertical velocity, what is the horizontal velocity, so that velocity also can be represented here, can be, or we can find out from this graph. And one more thing, just we have to see at what velocity that means for what condition we are reaching the maximum velocity, because we just vertical velocity is the rate of climb, horizontal velocity is symbol aircraft velocity. So at what velocity it is reaching maximum, so it means it is nothing but when the rate of climb becomes 0. So when the horizontal vertical axis, you see when the rate of climb is 0, then there we are reaching the maximum velocity. So maximum velocity of the aircraft is achieved when the rate of climb is 0. So we can just here we can say just say rate of climb is 0. So that is very important. Okay, so okay, I hope okay this how we are finding the maximum angle of climb and maximum rate of climb based on the vertical velocity and horizontal velocity graph, nothing but Hodograph, and especially this is for particular altitude, that is very important. Okay, climb Hodograph is drawn for particular altitude to define angle of climb as well as rate of climb. So now we will see one more thing, that is nothing but service ceiling and absolute ceiling. So that is also important, because service ceiling, just we can just see here. Let us take the vertical axis. Vertical axis will be yeah, okay. So vertical axis is nothing but a height. So it is the height. Then horizontal axis is nothing but rate of climb. So rate of climb. So in this, okay, we are drawing the line. So graph. So it is the curve is okay. It goes something like this. It goes something like this. So it means okay, here it is 0. Okay, so rate of climb okay from starts from 0 and reaches, okay, we can just say this at this point it will be maximum. Okay, and similarly okay, height also we can say from 0 to this, okay, increases. So here we are just going to find out two things. One is the absolute ceiling and service ceiling. Okay, so absolute ceiling is the altitude. Okay, we just say absolute ceiling is the altitude at which the rate of climb is okay, what to say, 0. That is what. So if you say this is the absolute ceiling, so absolute ceiling. So here okay, here it is nothing but it is the absolute ceiling, where okay the height is absolute ceiling is the altitude at which rate of climb is 0. Okay, so that is what okay we have to understand. So just here the rate of climb is 0. Okay, then service ceiling. Service ceiling is the altitude. Okay, service ceiling also is the altitude. So it is somewhere here. Okay, just we can say. So service ceiling is the altitude at which the rate of climb. Okay, so if you say this is the service ceiling, it is the altitude at which the rate of climb is 100 feet per minute. 100 feet per minute for piston engine. Okay, this is okay, we can just say this is the rate of climb. Okay, 100 feet per minute for, this is for piston engine, this is for piston engine. Then if the service ceiling okay achieved, service ceiling is the altitude at which or service ceiling at which the rate of climb is achieved, we can just say 500 feet per minute, 500 feet per minute. So this is for jet engine. So it's okay, service ceiling is the altitude at which the rate of climb is reached 100 feet per minute for piston engine, and if the rate of climb is reached 500 feet per minute, that is for jet engine. So that is one thing. Okay, just we have to okay, so this we can draw okay in the graph. Okay, so we can find out the absolute ceiling as well as service ceiling. So absolute ceiling nothing but where the rate of climb is 0, and service ceiling is okay where the rate of climb is reached 100 feet per minute for piston engine. And here one more thing is okay, rate of climb is okay is maximum when the height is 0. So this is what we say, this is nothing but we say as the this is nothing but we see as the rate of climb is maximum. So it is maximum. So that means at which the height is 0. So what we have to understand, rate of climb okay it becomes maximum where the altitude is 0. and then it is okay absolute ceiling and service ceiling also. It is based on the rate of climb condition. I hope okay it is clear. Okay, it is okay that graph okay clarifies okay how we are just finding the service ceiling and absolute ceiling. And one more thing is we have a cruisy ceiling. Cruisy ceiling also is there. Cruisy ceiling is the altitude. Cruisy ceiling is the altitude at which the rate of climb becomes okay. Rate of climb becomes that means this becomes 300 feet per minute. 300 feet per minute. So that is what okay. So service ceiling is not okay. That is achieved when the rate of climb becomes not service ceiling, cruisy ceiling. It is called a cruisy ceiling when the rate of climb is 300 feet per minute. So these are the three important that okay that with respect to the height, absolute ceiling, service ceiling, and cruisy ceiling. And we have one more ceiling that is called compact. Also we can say compact ceiling. So this is okay nothing but when the rate of climb is 500 feet per minute. So this is similar to the service ceiling. Okay, so service ceiling of the jet engine, because this is for jet engine. So okay, service ceiling of the jet engine that is achieved at the rate of climb equal to 500 feet per minute. Then compact ceiling also is achieved when the rate of climb equal to 500 feet per minute. Then cruisy ceiling is achieved when the rate of climb equal to 300 feet per minute. Okay, so that is nothing. Okay, so we are just defining the absolute ceiling, service ceiling based on the rate of climb. Okay, or then generally it is the altitude, absolute ceiling, service ceiling, or cruisy ceiling, nothing but it is the altitude where the rate of climb becomes particular value. That is what okay we have to understand. I hope this graph clarifies how to okay find out the rate of climb maximum as well as rate of climb equal to 0, and where the rate of climb okay reaches the cruisy conditions. So all those things okay we can just understand from this graph.